Right. So welcome. So this is our prototype of our credit score business tab. So basically, this is a tab for credit score analyst or any non-technical business people to check out the prediction and also the explanation that backed to our prediction. So here we have the customer profile for in the candidate pool. So here is the basic features for each candidate. We have their income, their salary, their their debt, and then we have a lot of other features such as age and occupation. So these are very interesting features. So here we have a large customer pool from zero uh, to 100K. So let's just randomly pick a candidate from our pool. So we will click the predict. So now it will start predict uh, by itself. So it will running from the inference first. So it starts to predict which class it belongs to. We have three classes: good, bad, good, poor, and standard. Right. So now it start, and then it will go through the sub process such as shape um, to analyze each features that drives to the class. And then we have casebook, the nearest training casebook that we can see if this candidate case are very close to what we have already inferred, so that we can see if these are like relatable to prove that our prediction are solid or not. Yeah, so and then it takes some time to explain the risk back from our explainable AI from our inferred from the inferred model, right? So it takes some time because it's using the reasoning model. Okay, so here is the result. So for this candidate, it's good uh, with 74.5% confidence. And then we have some business explanation from our reasoning model. It's GPT-04. And then these answers are backed by our explainable approach, such as our shape contribution and so on. So the explanation will explain like which features drives to the predicted class. So here we have a high confidence, right? Because of the excellent credit mix. So here is really that what drives to the predict class. But then here's the thing. He said it's a non-worth misclassification that we match from our casebook, from our candidate presentation represented casebook. So that it means that this prediction might be biased and might be worst misclassification part of our from our casebook. So that it might be very wrong. So that the recommend action below is that it has to be manual review like immediately. Because from cosine similarity, it indicates that it's 0.995 to worst misclassification type. All right. So the confidence that belongs to good is not trustworthy. All right. So this and then we have a shape diagram show indicating each features drive to which direction of the predicted class, right? And then we have some explanation of key drivers as well. And then we have a risk curve position. So this is using the PDP. So it shows our target customer is belong to um, which area of PDP trend from the global interpretation. So here we can see that uh, and also these PDP are like selected from our top three SHAP uh, features, so that like we can see that, for example, our target here is really belongs to the standard, and then the second place is the poor one. So meaning that the good position, the good class might be really wrong. Also, it's proved by the PDP curve. And then we also have a nearest casebook so that we can compare to our missed a really misclassification case type, and it's really similar considering the type and the feature driven, so that we can infer, like prove again that it might be a misclassification. And then we have the last one, which is hypothesis validation. It is initiate from the EDA, and then the EDA will have some bold directive hypothesis first to influence our downstream node, such as the feature engineering part, so that we train our model based on some of these hypotheses. And now we can see that based on this target customer, some can be supported, some still need to be tested, and some is really exploratory, meaning that we have to this is a future work that we need to analyze beyond the scope. Let's take another example. Right. So this is a negative class prediction, but it takes some time. So I'll go to our second tab. So our second tab is the model evidence that illustrate every explainable approach um, backed from the model. So here we can see all the we use different models, right? We train different models. So here we can see all the performance by each models. We have a confusion matrix here showing the amount of misclassification. And then we have shape B swarm also indicating the features drives to which class of prediction. We also have PDP and AO, and then we have a lot of casebook and shape dependence. And then we have a hypothesis that backed from the pipeline, that our agentic pipeline. I'll explain later from the third tab. So basically, this is really not for a non-technical guy, but for a critic score analyst, it is very essential for them to know what is the model training under the hood. So um, this is this is what we try to make in our second tab. Now we have the third tab, which is the most interesting part, because here we can actually train in the real time. And we can track the log in the real time from node to node. So here we have a log, right? Right. Right. So so here is the pipeline, and we can see that this is moving from one node to another back like until the very end of explaining risk. So my teammate has already introduced the whole pipeline, so I'm not going to introduce again. But here's the interesting thing. We can see all the traceable logs in the pipeline, and it is in real time that we can track. And then we can see like here, it's mentioned like which node LLM is calling, what is the model it's using, and what is the input token and output token that consume, and how much time it takes. And then it also illustrates the state key written. So here we can, so this is like how we make the contract of each node to all the downstream nodes so that they can communicate through the state, right? So here's what they write into the state. For example, for the dataset policy spec, where we write our plan, um, so it's going to write what is the missing column. For example, here we can inspect that we have a lot of uh, missing data in this field. So we probably gonna impute or drop this column. I don't know later. But from this node, we can tell like this node can plan what we should drop, what we should clip, or what we should transform from the data. So I'm not going to wait until the full pipeline running because it takes things some time. So what I'm going to do is I'm going to show you a full log that I have already been run. So here we can see it's very intuitive, right? So here we are from data from the plan we write, and then we generate our EDA hypothesis. That's some bold directive hypothesis first, and then to know what data we can transform from the feature engineering and also as well as the data pre-processing. And then after we generate the code for pre-processing node, uh, it might be have mistakes. So we have to validate it and review it. So here is the um, pipeline. We have some mistake here, so we repair the code and then we validate again. So here we have some loops that we trial and error, and then it goes to the feature engineering. So feature engineering, we also let LLM to code itself. So there are some mistakes as well, but after we repair it, it's continue to the next pipeline. So after we validate our feature engineering, we going to train the model, and then we evaluate the model. We make some diagnostics of what's the performance of each model because we train three models, right? We have the logistic regression and then some trees model, the decision model, decision tree model. And then we have the some different layer of um, explainable approach, both from global and local. And then we are going to bundle all these explainable diagram and the content into a bundle so that we pass all this analytics information into the end uh, for explainable uh, our explainable node to explain the risk of each candidate in the inference time. Right. So here we can see from each node here are uh, different features that write into the state one by one. Here, for example, the ED hypothesis, we have a lot of bold hypotheses that made in this node. So some node need to be tested. Some is for support. We have different type of hypotheses. Some are more safer. Some are like um, more exploratory. Right. So we have some error here. We can also check. Right. So basically, this is the main idea of the third tab that we have is basically you can track the log um, from this pipeline node to node. And this is mainly not for non-technical people, but for technical people who wondering how the pipeline is going, we have this visualization for you. And yeah, let's go back for the poll class then. Yeah, so for the poll class, it's also very intuitive, right? Um, because here we can see the shape. Most of the features they drive to the poll class, and there's very less blue bar that can pull it back to argue against this call. So it's it's very obvious that this is a very poor this is a very poor this is from a very poor class, and we should be very cautious to borrow the loan to this candidate, right? So have some key drivers as well. So the PDP curve also proved that this candidate it belongs to the poor class, right? It's very intuitive because it is 46 percentage um, belong to the poor class. So it's quite a lot, like almost a half beyond three class. Uh, yeah, so basically this is it. And the last tab that I'm going to show is the skills, because skills is how non-technical people can run agentic pipeline. So we have a very clear skill for each node. So for example, for the explain risk, we let them to know how we can reason step by step. So basically, we have two type of skills. First one is the non-reasoning skills. The second one is reasoning skills. They are different because for reasoning models, we let them to reason step by step. For example, we have the data transform planning, right? So we use reasoning model for it because we needed to reason each features to see if this feature need to be clipped or need to be transformed um, from the outliers. And the typical non-reasoning prompts from the node is um, code generation. So we need fully instruction, like strict instruction to not let the code generation to generate code, but strictly follow our instruction. So this is where we use the non-reasoning model. So there is a kind of different instruction type we use between reasoning model and non-reasoning model. Right, so basically this is it. That's it. And let me explain some risk limitation here. So I also have a import data set button here, but it is not usable here recently. But since our pipeline are quite generalized, so meaning that we are not only tailored for credit score project, it can be any financial domain projects that can be, you can just drop the data set into our agentic system, and then we can train immediately and through the pipeline. So this is our hope in the future, and it can be iterate from that direction. Right. So here we can also, and here we have also, we have all cached model that we train from pipeline as well. So this is it. I hope you enjoyed the video, and thank you very much. 哎，无所谓了。为什么？哦，这个 Zoom 的录音在哪儿啊？哦，我操，我还没结束录音。